Is it visible? ଦେଖାଯାଉଛି?
Yes, sir.
ତ ବ୍ଲକ୍ 2 ଆଜି ପଢିବା ମଡେଲ ସିଷ୍ଟମ ହାଇଡ୍ରୋଜେନ ଆଟମ। ସୋ ହାର୍ମୋନିକ ଅସିଲେଟର ପଢିବା, ରିଜିଡ୍ ରୋଟେଟର, ହାଇଡ୍ରୋଜେନ ଆଟମ 1, ହାଇଡ୍ରୋଜେନ ଆଟମ 2, angular momentum in one electron system। ତା ମାନେ ହଉଛି quantum chemistry will be applied in case of hydrogen atom, hydrogen atom 2 angular momentum and different. So classical harmonic oscillator and DG rotator. So first we'll start from harmonic oscillator. Okay. So what is harmonic oscillator? I'll show you in the PowerPoint. So is it visible? ଦେଖାଯାଉଛି?
Yes, sir.
Molecular mass ଆମେ last class ରେ ଦେଖିଥିଲେ particle in the box is useful for understanding how translation motion in various potential, particularly in one dimensional box କେମିତି translational motion ରେ କାମ କରୁଛି। Similarly, harmonic oscillator ଟା କୋଉଠି କାମ କରେ? Vibrational spectra ରେ vibration ହେଲେ will get harmonic oscillator। Translation motion ଗୋଟେ direction ରେ in one dimensionally ଗଲେ ତାକୁ translational motion। ହାର୍ମୋନିକ oscillator ହଉଛି vibration ହେଲେ harmonic oscillator। Rotation ହେଲେ two molecule will rotate with each other ତାକୁ rigid rotator ରେ। So a physical system in which some value oscillates above and below a mean value at one or more characteristic frequencies. So system often arrive when a contrary force result from a displacement from a force neutral position and gets stronger in proportional to amount of displacement, as in the force of exerted by spring. This stress is compressed. तो गोटे ए सिस्टम एक्जिक्यूट हार्मोनिक मोशन। कौन हार्मोनिक मोशन? गोटे स्प्रिंग जदि दब से स्प्रिंग टा भाइब्रेट हो, दैट सिस्टम इज नोन एज हार्मोनिक oscillator, the basic model for vibrating diatomic molecule। तो ये जो फोर्स of harmonic oscillator in a simple harmonic motion, the force acting on a system at any instant is directly proportional to displacement। A simple harmonic motion that force टा गोटे system ଉପରେ act କରିବ, that is directly proportional to displacement ମାନେ କେତେ ବାଟ ଗଲା। If the displacement of a system from a fixed point x, तो देखो linear restoring force F is directly proportional to x. So F is equal to minus kx. K is nothing but force constant. F is restoring force. X is the displacement. Okay. So this is a spring. But a spring टा अछि in spring काढ़ी छाड़ी देला। So what a force restoration हरा। So that's 4 is F is equal to minus kx. So that frequency of harmonic oscillator F is equal to ma। ଆମେ ଜାଣିଛେ force is equal to mass into acceleration। What is the acceleration? Acceleration is nothing but d square x by dt square। So F is equal to m d square x by dt square ରହିଲା। Now equation कौन 1 out 2। equation 1 कौन थला? This is equation 1। then equation 2 को equalize कर। तो equalize कला हम कौन पाइबा? equation 3 पाइबा। equation 3 टा कौन? d square x by dt square plus k x by m is equal to 0, where x is the displacement of harmonic। then तो x टा कौन होता displacement? So x can be represent x is equal to a sin 2 pi mu t। mu होचे frequency time 2 pi mu t। So A is nothing but amplitude. So dx by dt କେତେ ହବ? ତ ଆମେ obviously ଆମେ dx x ହଉଛି a sin 2 pi mu t ଆକୁ ଡେରିଭେଟିଭ କରିବା dx by dt is equal to a 2 pi mu cos 2 pi mu t. तो ଆମେ again differentiate. So double differentiate करियो dx by dt रे d square x by dt square is equal to minus a d pi square c square sin 2 pi mu t. तो ଆମେ ଡବଲ ଡେରିଭେଟିଭ କଲେ ଦେଖ cos ର ହବ sin sin ହବ ମାଇନସ ଫଙ୍କସନ ତାର ଯୋଉ 2 ପାଇ ଅଛି 2 ଟା ବାହାରକୁ ଆଇଲା ପାଇ ଟା ବି ବାହାରକୁ ଆସିବ mu ଟା ବାହାରିବ तो तार डबल कले 2 into 2 तो 4 square pi square mu square. So d square x by dt square is equal to minus pi square mu square x. x का बदले बसिला a sin 2 pi t बदले बसिला. So now minus taku a minus taku एपटू आइले. So we'll get this equation. So now equation 5 derived from equation 1, 2, 3, 4 and 5. So we'll get d square x by dt square plus 4 pi square mu square x. So ये होची equation 5. Now equating equation 3 and 5. 3 5 को equate करियो. So 5 टा एटा 3 टा कौन थला? तो 3 टा होची एटा. So ये 3 d square x by dt square plus k x by m is equal to 0. केता हबो d square x dt square 4 pi square mu square x ताकि इक्वलाइज कले यही पार्ट टा दिस पार्ट इज नथिंग बट kx by m. So this part is equal to kx by m. So from this value we will get me. In other words, frequency can be derived from this equation. So we'll get 1 by 2 pi k by m root over. So this is nothing but Hooke's law. So always we study Hooke's law in harmonic oscillator. So what is K? K is the force constant. M is the reduced mass. Okay. So if again we will get potential, classical treatment force related to potential. F is equal to minus dv by dx. F is equal to minus kx. So d minus dv by dx LA minus kx haba dv by dx is equal to kx. So dv is equal to kx into dx. Okay. तो एगुटाକୁ सेपटକୁ पळाइला kx dx ହେଇଗଲା. So now integrate both sides. So এই both sides ରୁ integrate कले dv ରହିଲା k 0 ରୁ x ଯିବ x dx. So we'll get v is equal to kx square meter. Now v is equal to half kx square. So ଆମେ ଏଠି v ପାଇଲେ v ମାନେ ଏନର୍ଜି କାଇନା potential energy ପାଇଲେ plus Hooke's law ପାଇଲେ. Now, this problem of simple harmonic oscillator occurs frequently in physics because mass at equilibrium under the influence any conservative force. So, simple harmonic oscillator. So, finally, we will get potential energy of function Vx is equal to half kx square. Okay. कौन पाइले half kx square. So half kx square. So this is the classical representation of classical mechanics representation of harmonic oscillator. देखा होची ना? Hello?
Yes, sir.
Hello? हाँ. Next. Harmonic oscillator will be utilized in quantum. Quantum रे केमती यूज हो. So listen, consider a mass m connected to a wall. But a wall रे एमती mass connected है. ए wall रे एंड spring रे connect है ताकू एमती टाने की भट के छाड़ दो. So ये stress हो. ये m आउची कम stress ये I0 थला. तो I0 रे 8 I stretch हला. स्ट्रेच है कि तो छाड़ देबी ये कंप्रेस है गला. So this is the initial situation, and this is the stretching situation, and this is the compressed situation. So in the three cases, I0, L0, L and A, all are the three conditions. So we will apply this situation in Hooke's law. M d square L by dt square is equal to minus K L by L, where K is the spring constant. Okay, a Hooke's law रे ये को पक्के. K large means steep spring. So x is equal to L by L 0 minus d square x by dt square plus kx is equal to 0. तो आमे कौन पकेवा ए x L by L minus x. So solution, if we solve this equation, we'll get kxt is equal to c1 cos omega t c2 sin omega t. So ଏଠି omega ହଉଛି କଣ k by m ର root over. Okay. So this is the equation will represent quantum mechanical treatment of harmonic oscillator. Xt is equal to a sin omega t plus half. So এই sin আমি জানতে sin a plus b is equal to sin a plus cos b. Again cos a plus sin b. So এই ইকুয়েশনটাକୁ ଆମକୁ ଭଙ୍ଗା ହେଇଛି. ତ ଆମର କଣ sin omega t plus phi is equal to sin omega t cos phi plus cos omega t sin phi. Xt is equal to a cos phi उल्टा है a cos phi. तो এই ভ্যালুটাକୁ ଆମେ ଏଇଠି ପକେଇବା a cos phi sin omega t a sin phi cos. ତ ଆମେ କଣ କରିବା sin omega t cos omega t ରଖିଲେ এই ଫ୍ୟାକ୍ଟରଟା ହଉଛି a cos phi, এই ଫ୍ୟାକ୍ଟରଟା ହଉଛି a c1 a cos phi c2. ତ ଟିକେ ଦେଖ କଣ ହେଲା. x ଫ୍ୟାକ୍ଟରଟା xt ହଉଛି ଇକ୍ୱେସନ. ଆମେ sin omega t plus phi को भांगिले. ये लिखो. We'll go to the next slide. Next is C2. C2. So x is equal to 0 is equal to C2 is a dx by dt. And we will differentiate at t is equal to 0. So we'll get dx by dt 0 c1 omega. तो xt a cos omega t ଆମର ଏଠି କଣ ଥିଲା xt c1 c omega t. तो 8 cos omega t omega पर k by m half fx dv by dx. So vx is minus, so derivative करियो एटी v को fx फंक्शन रे derivative करियो f of x ds plus cos k by 2x square. So all are derivative. ठीक है, देखिए दिया derivative. Derivative d to the power v to the power x. So k by 2x square. So all are kono derivative integration will be used in quantum chemistry. Kx half m dx by dt square is equal to half m omega square a square sin square omega. So kinetic energy is equal, sorry, total energy is equal to kinetic energy plus potential energy. So here we will get kinetic energy half m omega square a square sin square omega t plus half k a square cos square omega t. तो ये दीटा कौन मिसिले टोटल एनर्जी. सो आमे कौन आधा कॉमन अछि k स्क्वायर बाय 2. एठी देखो a स्क्वायर बाय 2 k a स्क्वायर बाय 2 कॉमन sin square omega t cos square omega t. So total of k a square by 2. So this factor will be 1. I mean, say sin square omega t plus cos square omega t 1. So ଏବେ ଦେଖ ହାର୍ମୋନିକ ଅସିଲେଟର ଡାୟାଟମିକ ଦିଟା ଆଟମ. ଆଗେ ଆମେ କଣ ମନୋ ଆଟମିକ ରେ ଥିଲା ଗୋଟେ ସ୍ପ୍ରିଙ୍ଗ ଟା ଲାଗିଥିଲା ୱାଲ ରେ ଆମେ ତାକୁ ଟାଣି ଦଉଥିଲେ. ଏବେ ଦିଟା ଆଟମ ଲାଗିଛି m1 m2. ଆମେ ସ୍ପ୍ରିଙ୍ଗ ଟେ ଟାଣିବା, then we will spring stress କରିକି ଛାଡ଼ିଦବା. So we'll get harmonic motion, vibrational square motion here. So देखो m1 d square x1 by dt square is equal to k x2 minus x1 minus l2. So देखो ये x2 minus x1, okay, minus l0 होता है initial position. Similarly, m2 d square x2 by dt square minus k x2 minus x1 minus l2. So 1 plus 2 gives d square by dt square. So m1 x1 plus m2 x2 is equal to 0. So here mass is the reduced mass. X factor is m1 x1 plus m2 x2 by m. So m is equal to m1 m. So we'll get this equation. Equation that take out 3 slide ta dekhi diya. We'll go to the next step. So next slide. Harmonic oscillator of a diatomic molecule d square x2 by dt square minus d square x1 by dt square is equal to minus k m by 2 x2 minus x1 minus l3. So k by minus k m1 x2 x1 l0. Mu is equal to m1 m2 by m1 plus m2. This is the reduced mass. So reduced mass is equal to m1 m2 by m1 plus m2. So mu, in this mu will be mu d square x by dt square plus kx equal. Two bodies problem has reduced into one body problem with a reduced mass. So we'll get a reduced mass here. So here frequency is equal to k by mu the root over. Okay. So internuclear potential. So internuclear potential means internuclear distance and two molecule, two atoms will close with each other. So this is the graph. This is potential axis, displacement axis. So K will be large. So potential will be low. K small. Here is K small. Here is the so harmonic motion. K large. Here is K small. Vx is equal to half k square. K is the force constant. So here a bond length versus molecular potential. Here potential energy versus displacement curve in harmonic oscillator. Here molecular potential versus internuclear distance. The bond length. So this will look like a parabola. Only lowest one of two vibrational levels are coupled with each other. So this is the graph of different harmonic oscillators. So these are the study of harmonic classical harmonic oscillator as well as कौन ଆମର ये quantum mechanical operator. So next we will study classic ଆଉ ଟିକେ ଦେଖିଦବା ଆମେ harmonic oscillator. ତ ଆମେ ପଢିଲେ harmonic oscillator କଣ? So first ଆମେ ପଢିଲେ particularly in one dimensional box. Vibration will occur in harmonic oscillator, rotation in rigid rotator. So this is a system execution of harmonic motion is called harmonic oscillator. So it is a basic model for vibrating diatomic molecule. F is equal proportional to F minus S. Okay, ଗୋଟେ slide just ଦେଖେଇ ଯାଉଛି for a recap purpose, restoring force. So this is the derivation second law of Newton's second law F ma ru will derive equation d square x by dt square plus kx by m 0. Or displacement of harmonic a x is equal to psi a sine 2 pi and तारा डेरिवेटिव है then double derivative, so we'll get this equation. Then we'll get potential energy here. F is equal to minus dV by dx. F is a minus dV by dx minus x. dV gets dx. So integrate in both sides. Okay, ds. So we'll apply this in harmonic oscillator, simple harmonic oscillator in potential. So this is a single diatomic or monoatomic molecule on the wall. Wall ଉପରେ ହେଲେ କ'ଣ equation হবে? Then this will be applied in the equation, general x equation, x2 is equal to a sin omega t phi. Okay. So we'll go to the rigid rotator. तो रिजिड रोटेटर कौन है क्लासिकल रिजिड रोटेटर दीटा आटम लगी M1 M2 दीटा आटम बॉन्ड विल बी देयर दीटा मॉलिक्यूल केमती हुए बॉन्ड गोटे आटम आटम मिसिकी गोटे बॉन्ड तैयारी करती दीटा आटम बॉन्ड रे थांती सो विल रोटेट दिस मॉलिक्यूल डायटोमिक मॉलिक्यूल दीटा आटम so that will rotate through its axis like empty rotate kariyo. This is M2 M1 and this is the center of mass. Center of mass ଆମେ ଜାଣିଛେ physics ର center of inertia ଆର center କୁ କହନ୍ତି center of mass. So this is a to center of mass through distance r2 r1 m1 ଟା r1 ର distance ଅଛି M2 R2 distance ଅଛି total distance ଅଛି R. Okay. तो जो R हैला तो we'll get kinetic energy केते पाइबा तो kinetic energy K is equal to half M1 V1 square ଆଉ M2 ର କେତେ ପାइबा half M2 V2 square दिटा मिसेइबा तो मिसेइले half M1 फर आसीबो कोन M1 जागारे हमें कोन पकेया ए R1 square. So M1 R1 square half M2 R2 square. କାହିଁକି ପକେଇବା ଆମେ ଜାଣିଛେ I is equal to M1 R1 square inertia moment of inertia is equal to M1 R1 square plus M2 R2 square mu R square. So inertia moment of inertia ଜାଣିଥାଉ physics ରେ ଗୋଟେ ମାସ୍ ଥାଉ ଗୋଟେ rotational motion ରେ when a molecule atom or object will rotate with each other so we'll get a moment of inertia. So moment of inertia I is equal to m1 r1 square plus m2 r2 r ହଉଛି radius so we'll get a mu so mu r2 square. Angular momentum केते पाइबा L is equal to I omega. I हଉଛି L हଉଛି angular momentum, I हଉଛି moment of inertia, omega हଉଛି कौन frequency. So K is equal to L square by 2y. L square हଉଛି angular momentum, I हଉଛି moment of inertia. So if we'll put this equation, so now the quantum treatment of rigid rotator in two-dimensional box. A two-dimensional box रे rigid rotator काम करे. Okay, so so what is the equation here? It's a time-dependent equation minus h square 2 mu d psi square xy dx d square x plus d square psi xy d square y r is equal to rg e psi xy. So this is a two dimension. So we have two coordinates x coordinate and y coordinate. तो x कोऑर्डिनेट रा डेरिवेटिव है जी y कोऑर्डिनेट रहा। सो हम जानते हैं ये स्क्रोडिंजर इक्वेशन टाइम इंडिपेंडेंट कोऑर्डिनेट इक्वेशन सॉरी स्क्रोडिंजर इक्वेशन। तो कार्टेशियन फंक्शन एक्स वाई टू डायमेंशनल जिनिस अछि ताकू कोन माइनस ए स्क्वायर बाय 2 म्यू होची रिड्यूस्ड म 1 by r0 square d square phi by d phi square is equal to e phi 0. Okay, so we get the e phi 0. So two linear independent solution are phi a e phi and a e 100. So this is the exponential function at phi रा लेखा। तो देखो ये रिजिड रोटेटर केमितिया ରହିଛି ତାର m1 m2 ସହିତ କେମିତି ଆମ ରିଜିଡ୍ ରୋଟେଟର କାମ କରିବ। m1 ତ ଏମିତି ବୁଲୁଛି ଆର ଦିଆହେଇଛି m2 ଏମିତି ବୁଲିବ m1। So this is center of mass. So center of mass doesn't mean it will be remain at the center। देखो m1 ର distance କୋଉଠି center of mass ରୁ r1 m2 ର distance center of mass ରୁ r2। So it is doesn't mean r1 is equal to not necessarily r1 is equal to r2। So total distance r, so r is equal to r1 plus r। So rigid rotator center of mass। So ଆମେ ଜାଣିଛେ kinetic energy is equal to half mv square। ଏଠି instead of m in rotational motion we get moment of inertia half mv square। So v square बदल एठी frequency ର square angular momentum omega square half mv square ଜାଗାରେ half I omega square। So L square by 2I L ହଉଛି କଣ angular momentum I ହଉଛି momentum velocity। ତ ଆମେ ଏଇ ଓମେଗା ଜାଗାରେ L is equal to I omega omega is equal to L by I। So omega ଜାଗାରେ L by I ର square ପକେଇବେ। So we'll get L square by 2I। So here L is the angular momentum, I is the moment of inertia, omega is the angular velocity। कौन आना angular velocity। So I moment of inertia is m r square हुए एटी m दिटा diatomic molecule अछि atom अछि। So mu बसियो mu होची reduced। So I is equal to mu r square। So this is simple equation kinetic energy equation। Please look at this equation carefully। ये देखो आगे बुझी पारछो ना नहीं just
ଓ ପିଠି ପିଠି ଝାଳ ତମରି ଝାଳ ବାହାରୁଛି।
kinetic energy half m omega square L square by 2। So N is the angular momentum, I is the momentum inertia, omega is the angular velocity। So here moment of inertia is equal to a mu r square। So mu is the moment of here। Okay. Next we'll go to the next slides। So here again Schrodinger equation, we will apply Schrodinger equation here। H psi is equal to E psi। So H Hamiltonian operator will operate on the wave function, will get eigenvalue energy and psi। So here Hamiltonian operator is a energy operator. So both are equal to kinetic energy and potential। So potential energy assume to zero। So if we assume potential energy zero, so we'll get S Hamiltonian is equal to only Kinetian. So as you know from the previous side, so we'll get a L square by 2I Kinetian. So L square by 2. So here L is the angular momentum operator. L square can be written Ls square, Ly square, Lz square. तो देखो केमती ହେଇଛି L square L1 square तो केमिति देखो ए स्लाइड आगे देखो से स्लाइड तापर देखियो so we'll get the equation here. So ଏଇଗୁଟା ମାନେ ଆମର kinetic energy potential energy ମିଶିକି total energy तो ଏଇଟାକୁ potential energy ଏଠି 0 तो kinetic energy ଖାଲି ମିଶ तो ଏଠି L ଟା କଣ ହେଲା angular momentum तो angular momentum in three dimensional x coordinate रे ଗୋଟେ y coordinate रे z coordinate so we get this one. Next so ଆମେ ଜାଣିଛେ angular momentum we will get angular momentum in quantum treatment. So y coordinate रे dz momentum minus z of py. So we'll get this quantum IH h bar h by 2 pi eta minus I h mu y d by z z d by ସେମିତି ly ରେ ହବ lz ରେ ହବ ତ ଦେଖ କଣ ହେଇଛି okay so we'll get this angular momentum in different coordinates okay ଦେଖା ହଉଛି ନା ନାହିଁ anyone
Yes,
respond
ଦେଖାଯାଉଛି।
ହଁ ଓକେ ଓକେ सो आमे पढ़ुते रिजिड रोटेटर एमदिया गोटे रिजिड रोटेटर मोस्ट एग्जाम रे आसीबो सो यू विल ड्रा ए डायग्राम लाइक दिस एमदी गोटे रिजिड रोटेटर डायग्राम करिवो डायग्राम कर साइला परे तमे तार काइनेटिक एनर्जी जस्टिफाई करिवो हाफ एमवी स्क्वायर बड़ा हाई ओमेगा स्क्वायर आई होची मोमेंटम इनर्शिया ओमेगा होची एंगुलर वेलोसिटी एल होची कोन एंगुलर मोमेंटम तो ई फॉर्म को आनिबो रिड्यूस्ड मास तापरे आर एनर्जी then we will get lx ly lz ର equation देखो quantum equation then transformation of coordinates in different direction okay in different direction रे देखिबो just a minute. तो देखो इटा x coordinate y coordinate and z coordinate so x coordinate रे r sin theta cos phi so theta कोन theta this angle okay आउ phi होची this angle x आउ l रो angle होची phi so this is theta and this is so this is the equation trigonometrical equation so x is equal to r sin theta cos phi y is equal to r sin theta cos phi x y same but z only r cos theta so we'll get only r cos theta here okay so Next. So आम जाने एलएक्स को कौन पकेवा एलएक्स रा ये इक्वेशन एठी आमे कौन पकेवा सब इक्वेशन को पकेवा आईएच तो एक्स डी वाई जगह रे एठी जो एक्स डी बाई डी जेड एक्स टी बाई डी एक्स इट सब को डेरिवेटिव so we'll get lx ly lz in this form okay এই ফর্মরে ଆମେ lx ly lz পাଇବା तो lx ly lz पाइले ଆମେ କଣ ପାଇବା तो ଦେଖ ସବୁ ଇକ୍ୱେସନ ଟା ଦେଖିଦିଅ କେମିତି କଣ ହେଇଛି ତାପରେ ଆମେ କଣ କରିବା ଡବଲ ଡେରିଭେଟିଭ କରିବା ଏଲ ସ୍କୋୟାର ତା ସ୍କୋୟାର ସବୁ तो स्क्वायर नेले we will get it this is difficult question trigonometry ସବୁ question so sin theta del square ये सब स्क्वायर ହେଇଛି डबल डेरिवेटिव ହେଇଛି तो डबल डेरिवेटिव रे sin ର cos ର sin so we will get this equation then so this equation as h psi is equal to e psi हम जानते हैं स्क्वायर इक्वेशन एटी h बदले कौन l square by 2 e कोड आइला हम प्रीवियस साइड रो जिबा एटी हम देखतले देखो एटी h टा कौन l square by 2i तो हम एटी जिबा l square h square by l square by 2i is equal to psi तो a square l square psi पहिले काम कौन मिलियो तो आपको ई टर्म टाको हमें 1 बाय टी 2i मोमेंट से अलग लिखि दवा l स्क्वायर होची कोन l x स्क्वायर देखो l स्क्वायर जगह रे एति को टर्म पड़ी एटा कोड होइला हम जानते l स्क्वायर ता ई ओके तो l स्क्वायर कोन l स्क्वायर रेडी पड़िबो तो पड़िले हमर कोन हबो इक्वेशन ये देखी दियो केमती इक्वेशन पढ़ी जस्ट बड़ इक्वेशन तो देखी हम डायरेक्ट से दिखाई कौट कौन है टे देखिए okay so we'll go to the next slides so now psi is a function of theta and phi both are independent of each other so कौन के का पे डिपेंड करंती थीटा गोटे फंक्शन फाई गोटे so psi theta comma phi is equal to psi theta phi theta comma phi. So we'll get this function now multiplying sin square theta in previous equation. The previous equation था हमें कौन sin theta सब बोलते. So we'll get this equation like this. So here this point this beta will be this term. A term का में beta का. So the equation will be like this. So beta जगह रे यार जगह रे beta. So substituting this value of psi. तो कितने बड़ा बड़ा इक्वेशन हो रहा है तो sin theta sin phi आरबा तो प्रीवियस इक्वेशन रो हम आइला इक्वेशन रो इक्वेशन का आइले सब वैल्यू ऑफ psi हमें जो psi रा वैल्यू को एठी पके नाउ डिवाइडिंग थ्रू out by psi को पूरी डिवाइड करले will get so we'll assume this one m square so it m square वाले this a total will be m square होची mass of the atom so now theta varies from 0 to pi pi varies from 0 to so theta pi होची गोटे angles 0 ru pi degree हबो और 0 ru 2 pi degree हबो so we have so finally we have this one is equal to m square ये टर्म टा एठी पड़ेगा सो ये एठी रहिला ये गोटा एपटू पड़ेला we'll get the equation so this is the standard equation of Schrödinger equation general equation we'll compare this equation with the Schrödinger So now we'll apply this equation in normalized. Normalized means data wave function will be combined with each other to form one. So psi रे psi star ମିଶିଲେ 1. So ଏଇଟାକୁ ଏଇ function 0 to 2 pi normalized equation n square is equal to 2 pi 1 n ର value 1 by root pi. So we'll get this one. So it's पूरा mathematical expression ସବୁଆଡେ तो ତମେ ଟିକେ derivation ଟିକେ ଦେଖିବ. Then solution of theta equation. Theta equation ର solution କେମିତି ପାଇବ? So this equation from this equation ଆମେ ଜାଣିଲେ a minus m square ଏପଟେ ଥିଲା ଇଏ ଏପଟେ plus m square. So x is equal to cos theta 1 minus x square is equal to sin square theta. So 1 minus x square is equal to sin theta. So dx केता हो minus sin theta dt. So we will derive this equation derivative. Now the equation becomes equation केमती आइजु ए theta रो value 80 पके. So पके देले we will get the function like this. Then theta रो function theta रो phi रो normalized equation 80 पके. तो psi theta phi कौन हबो theta psi theta phi theta. तो एठी equation केते बड़ equation एठी सब सेउटो आसिला आ जगह सेटा. So finally, आम कौन equation आम जो normal rotational spectroscopy पाउथिले from quantum mechanical treatment we will get this equation beta L plus L plus 1 8 pi square I by S square. So here Ig energy, I is the moment of inertia, H is equal to Planck's constant. Okay. So E will be like L into L plus 1 H square 8 pi square I. So in spectroscopy, आमे rotational spectroscopy रे कौन कौन दी energy ये होच quantum mechanical treatment रो ये होच spectroscopical treatment. J आमे जाने चे J into J plus 1 H square 8 pi square I. J is a rotational quantum number. J 0 1 2 it L होची 0 1 2 3. So this is the comparison between spectroscopical treatment and rotational vibrant. Okay. तो देखो आमे आउ थरे आकु रोटेशनल रो टिके देखिदवा एमती कौन हला. तो ये होची कौन रोटेशनल स्पेक्ट्रोस्कोपी रो रिजिड रोटेटर कौन आमे रिजिड क्वांटम. सो क्लासिकल रिजिड रोटेटर इना क्लासिकल ये होची क्वांटम मैकेनिकल. तो ये इनर्शिया मास केमती अछि R1 R2 R1 एटा कगे लिखिबो तापर इक्वेशन काइनेटिक एनर्जी रो इक्वेशन लिखिबो इन टर्म्स ऑफ रोटेशनल स्पेक्ट्रोस्कोपी. तो लिखि साइला परे तो हमें मोमेंट ऑफ इनर्शिया आई म्यू आर स्क्वायर ए टर्म तक आनी. तो ए टर्म को आनी साइला परे हमें कोन करिया तापर म्यू इज इक्वल R1 R2 स्क्वायर Maria. So it's mu e mu एटा स्कोरिंजर इक्वेशन पकेया तापर तार को काइनेटिक एनर्जी को आनी. ओके तापर l स्क्वायर lx स्क्वायर ly स्क्वायर तो l वैल्यू क्वांटम रखिया. ये l सब डायग्राम सब ड्रॉ करिया. So you have no way to escape. तुम सब कर किटमटिया जिनस यहाँ तेणु तुम कर आटलिस्ट ड्रप करके कौन इक्वेशन फिक्वेशन तुमको देखा पड़ो कारण आधे थ्योरी कम क्वेश्चन अधिका क्वेश्चन से क्वांटम केमिस्ट्री टी मैथमेटिकल ट्रीटमेंट सब ओके देखा ना नहीं यस
Yes, sir. ଦେଖାଯାଉଛି।
देखो सबुआड़े मैथमेटिकल ट्रीटमेंट तुमको अबाया लगुव बट तुमको सब पड़ो तो एनर्जी सब डेरिवेटिव टिके जान तो आम अब यूनिट 5 कौन पढ़ले टे रिक्याप करदे हार्मोनिक ऑसिलेटर कौन टे रिक्याप कर जन पचर So harmonic oscillator, harmonic motion no harmonic oscillator. It is basic model of vibration of diatom molecule. देखी दिया पढ़ी दिया सब लिखा है पढ़ो मु खाली आगो पछ कर दो स्लाइड्स स्क्वायर x by dt स्क्वायर हम for diatomic point equation harmonic oscillator internuclear potential classical rigid rotator तो rigid rotator diagram करियो केंति कहले kinetic half m1 v1 square and t square तो equation रो पके तो ये होची डिफरेंट कोऑर्डिनेट्स सही छी ट्रांसफॉर्मेशन कोऑर्डिनेट्स so next we will go to the another slide that is hydrogen atom कौन जी हाइड्रोजन एटम को दी so is it visible to all of you देखा होची yes hello students is it visible
Yes, sir.
Hmm. Now we will study quantum hydrogen atom, treatment of hydrogen atom in quantum chemistry. So, we shall revise the hydrogen atom content. ଆମେ ଜାଣେ ହାଇଡ୍ରୋଜେନ ର ବୋର୍ସ ମଡେଲରେ ଲାଇନ୍ ସ୍ପେକ୍ଟ୍ରା ପଢିଥିଲେ। ଆମେ ଜାଣିଥିଲେ ଫାର୍ଷ୍ଟ କ୍ଲାସରେ En is equal to minus r 1 by n square. 1 by n ହଉଛି different କଣ orbitals of Bohr atom, different energy states. तो r by n square, तो z ହଉଛି କଣ z by n square ହୁଏ, ଏଠି z ହଉଛି 1 hydrogen. So we have considered the hydrogen atom before in our discussion, Bohr model and energy quantization. Energy quantize means energy we can calculate. The model derived an expression for quantized energy associated with particular electron. So En କେତେ ବାହାରିଥିଲା ମନେ ପକାଅ, ଏଗୁଡ଼ା just En is equal to minus Z ହଉଛି atomic number, E ହଉଛି electron mass, M ହଉଛି mass of electron, 8 epsilon 0 is square Planck's का 1 by. So this is total will be minus R 1 by n square. R is equal to Rydberg constant and expresses the energy in terms of it required to remove an electron. So this is the hydrogen atom of Bohr atomic model treatment. Energy of nth orbit energy. So hydrogen, if you will apply this energy in Schrodinger equation, of course the Bohr model uses the quantization scheme that only yields energy, but not electronical wave function. Wave function is देखा. So it was derived So it was derived years before wave mechanics was introduced. We shall now examine. So ଆମେ କଣ କରିବା, ସେଇ wave mechanical term ରେ ହାଇଡ୍ରୋଜେନ ର କଣ ବାହାରିବ। So ଆମେ ସେଇ energy ଆଉ nth orbital energy କୁ will represent in quantum Schrodinger equation. ସବୁଠି Schrodinger equation. ଆମେ ଯାହା ଯାହା ପଢୁଛେ Schrodinger equation will apply in all the system. So it is h square 8 pi square mu d square dx square plus d square by dy square plus d square by d square. So psi x y z minus half h by 0 z square by r psi x y z equal to e psi x. Here the potential energy is the Coulombic attraction between bodies. हेलो, ये म्यूट करो. So दिखाओ ना, so students, is it visible?
Yes, sir. Yes, sir.
Okay. So this is a hydrogen energy term को in terms of quantum Schrodinger equation रे represent करा. So ଏମିତି ସେଠି ଯେମିତି x coordinate y coordinate r coordinate ଥିଲା, x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, z is equal to r cos theta. So r is the equal to x square y square z square root over. So time independent Schrodinger equation is never solved in Cartesian coordinates like other central coordinates. So listen, this is Cartesian function. So x, y, z e ହଉଛି ଏଇଠି ଇଲେକ୍ଟ୍ରନ୍ ଟା ଅଛି, ଆର x coordinate, y coordinate, z coordinate। ଏ କୋଉ ଆଙ୍ଗେଲ ରେ ଅଛି, x z ରେ theta ଆଙ୍ଗେଲ ରେ, ଆଉ x ଆଉ y ର ମଝିରେ ଇଏ phi ଆଙ୍ଗେଲ ରେ ଅଛି। So this is Cartesian coordinate। Here is never solved in Cartesian। So time independent Schrodinger equation को हम Cartesian coordinate रे solve. That is spherical coordinates. So quantum in hydrogen atom. So this is the quantum mechanical treatment of hydrogen. Minus a square at pi square psi xy ଯେମିତି ଆମର d square a Laplacian operator delta square d square by dx square d square by dy square d square. तो ये टोटाल हଉଛି x square. एक्स वाई जेड कोऑर्डिनेट ଅଛି ବୋଲି ଆମେ ତିନିଟା କୋऑर्डिनेट ର एक्स वाई जेड लिखୁଛେ ଆମେ ଜାଣିଛେ a ସ୍କୋୟାର 8 ପାଇ ସ୍କୋୟାର m ହୁଏ ଏଠି μ ହୁଏ ଯେହେତୁ डाई एटॉमिक μ ଅଛି माइनस हाफ पाई जे जा थला सब सेम. So time independent Schrodinger equation is never solved in Cartesian coordinates like other central force problem. When the Schrodinger's equation is converted to spherical coordinates, it can solve by separation of variables. Assuming that, assuming that uh, wave function is product of two functions, one is described already. So this is a quantum hydrogen like other three-dimensional problems. So देखो psi r theta phi. So r होची दीटा radial wave function and three problem. The hydrogen atom wave parameterize three integration L A M. So n principal quantum number L azimuthal magnetic quantum. तार सब गोटे गोटे बाहर. So principal angular magnetic quantum number will be derived from this radial wave function. So r टा होची radial wave function. So it कौन application of the Schrodinger equation in hydrogen spectra, hydrogen atom. So listen, कौन देइची potential energy ଗୋଟେ potential energy electron ର କେମିତି. So ଆମେ ଜାଣିଛେ E half ଆମେ Q1 by Q2 by R square. तो ଆମେ ଏଇଠି potential energy minus E square by 4 pi epsilon R. ये कौन electrostatic force of attraction between two electrons. So if you write in three-dimensional in time-independent Schrodinger equation, that will be del square d square by dx square plus d square by dy square plus d square by dz square 2m h bar square e by v psi x. So this is the equation of time-independent Schrodinger equation in three dimensions. So hydrogen like atom also satisfy the hydrogen like atom माने हाइड्रोजन गोटे इलेक्ट्रॉन लिथियम प्लस 2 रो केटा इलेक्ट्रॉन लिथियम तीनटा तादो दुईटा इलेक्ट्रॉन हला सी भी गोटे इलेक्ट्रॉन हीलियम प्लस हीलियम रो दुईटा इलेक्ट्रॉन तार भी हीलियम प्लस रो गोटे. तो ये होची हाइड्रोजन लाइक एटम और आइसो इलेक्ट्रॉनिक स्पेसिस ऑफ हाइड्रोजन जोटी गोटी गोटी हाइड्रोजन इलेक्ट्रॉन था इस ता ପାଇଁ भी this one is applicable. Same thing आदरे replace e square with z square. तो z हर वैल्यू हाइड्रोजन 1 हीलियम रो 2 लिथियम रो 3 हम चली किंतु इक्वेशन will remain same. So पचार तो हीलियम प्लस और लिथियम 2 प्लस रो सो हाइड्रोजन जहाँ हो लिथियम 2 प्लस से हो खाली जेड जगह रे 1 पकेव हाइड्रोजन रो लिथियम रो केते पड़ियो 3. So use appropriate reduce mass m1 m2. So the potential central force depends on between this transfer of spherical model. So ये सेठी जेमती यूज करथले हमें सेमती डिफरेंट कोऑर्डिनेट्स x कोऑर्डिनेट z कोऑर्डिनेट y ताले थीटा फाई. So ये काटे हमें जानचे r is equal to sin theta cos phi, y is equal to r sin theta sin phi, z is equal to y cos theta. So आपको सबू जानको कौन inert coulombic potential force. So we'll apply in the Schrodinger equation. We'll get like this. 1 by r square d by dr, r square d psi by dr, plus r square sin d by d theta sin theta d phi d psi by d theta r square. So we'll solve this equation will come from r theta sin theta. Double derivative Schrodinger कले equation आसे. Question लिखिले. Question easy. तमे लिखिले it will be easier to you divide कोठी कोण equation होते. So application Schrodinger equation apply when in a r value solution of r theta and phi. Equation is separable. Solution may be produced three functions psi r theta phi r r f theta g theta. So we can separate equation 3 into 3 separable differential equation depending on coordinate. So r theta and phi. So these are different coordinates, angles of. ତାଦେହରୁ ଆମେ ସେପାରେଟ୍ ଭେରିଏବଲ୍ ଅଛି ତିନିଟା ଭେରିଏବଲ୍ r ଅଛି r theta ଅଛି r phi ଅଛି ତ r theta phi କୁ ଆମେ କଣ ହବ so d by d psi by dr ଆମେ ଏମିତି ସମସ୍ତଙ୍କର ଡେରିଭେଟିଭ୍ କରିବା ତ ଡେରିଭେଟିଭ୍ କଲେ ଆମେ ଏଇ ଜିନିଷ ତ ଆମେ ସେଇ ଇକ୍ୱେସନ୍ 2 ରେ ଆକୁ ସବୁ ଆପ୍ଲାଏ equation apply kale we get multiply equation 5 by r square sin theta hele we get equation 6. ये होची equation 3 equation 2 equation 3 2 3 देखो डेरिवेटिव ऑफ इक्वेशन 3 इक्वेशन ए 3 को डेरिवेटिव बात कर ई psi by dr हैला ई सब रो डेरिवेटिव पर्सनल डेरिवेटिव तब substituting them into equation 4. So equation of 4 equation 3 रा डेरिवेटिव होला equation 4 रे आकु कोन अप्लाई ये पुट कर तो पुट कले equation 5 तो equation 5 रे sin theta t रे डिराइव कोन मल्टीप्लाई तो मल्टीप्लाई हेले you will get equation 6. So solution of Schrodinger equation आदरे केमति solution बाहर करियो by deriving value of r theta and phi. तो आपको azimuthal लिखो d square g d square m square g ताकू कोन डिराइव करिके थीटा so solution of Schrodinger equation so equation को solve कले will get theta and phi जेम तादरे बाहर करथले हम rigid rotation equation theta phi तो आमे कोन पाइबा गोटे इक्वेशन पाइबा रेडियल इक्वेशन आ गोटे एंगुलर इक्वेशन दिस इज वेरी इम्पोर्टेंट सो आमे सॉल्व करके आमे पारिबा स्क्रोडिंजर इक्वेशन को गोटे रेडियल इक्वेशन तो r थबो आ गोटे होची एंगुलर इक्वेशन एंगुलर मोमेंटम a रो वैल्यू ओके दीटा इक्वेशन रेडियल इक्वेशन पाइ एंगुलर सो सॉल्यूशन इथु कोन पाइबा आमे कोन डिफरेंट क्वांटम नंबर्स आमे क्लास में पढ़िथिले तो यही हाई क्वांटम मैकेनिकल ट्रीटमेंट रो भी आमे डिफरेंट क्वांटम नंबर्स पे आमे जानि चारि प्रकार क्वांटम नंबर थाए गोटे होची प्रिंसिपल क्वांटम नंबर तापरे अजीमुथल क्वांटम नंबर मैग्नेटिक क्वांटम नंबर स्पिन क्वांटम नंबर आमे देखो आधरे कोन आमे स्पिन क्वांटम नंबर पाइया तीनटा क्वांटम नंबर पाइबा ए n रो वैल्यू l रो वैल्यू n सो n रो वैल्यू तो n स्क्वायर पाइबा l रो वैल्यू आमे 0 1 2 3 m रो वैल्यू आमे जानि छे l रो जा हबो माइनस l रो प्लस l थ्रू 0 आमे पाइया धर हमर l रो वैल्यू 2 हैला m रो वैल्यू केते हो -2 -1 0 +1 +2 तो माइनस l रो प्लस l थ्रू 0 then 3 है -3 -2 -1 0 +1 +2 +3 so this is the actual method so the predict energy can be predicted En is equal to minus E0 by n square so n square holds principal quantum number E0 holds standard energy gote nth orbital ground state energy n square जो orbital पर n square so एमती क्वांटम नंबर बाहर करी हबो आदिरु So we'll get a different orbitals. तो ଆମେ ଆଉ ଥରେ ଆଗ ଦେଖିଦେବା ରେଡି ହାଇଟ୍ ଆଚ୍ଛା ହଁ ତ ଏଇଠି କ'ଣ ଏନର୍ଜି ପାଇଲେ ତ we'll get ହାଇଡ୍ରୋଜେନ୍ ଆଟମ୍ ରେଡିଆଲ ୱେଭ ଫଙ୍କସନ୍ କ'ଣ ଇଏ ହେଉଛି ଡିଫରେଣ୍ଟ ରେଡିଆଲ ଦେଖ ହାଇଡ୍ରୋଜେନ୍ ରେଡିଆଲ ୱେଭ ଫଙ୍କସନ୍ କେମିତି ବାହାରିବ n1 ମାନେ ପ୍ରିନ୍ସିପାଲ କ୍ୱାଣ୍ଟମ ନମ୍ବର 1 ହେଲା l ହବ 0 n1 s ପାଇଁ n1 ମାନେ ଖାଲି ତାର s ଅର୍ବିଟାଲ ପାଇଁ l ହଉଛି 0 so we will get a radial wave function like this. If n is equal to 2, we'll get L is equal to also 0. So we'll get radial. So a principal compound quantum n2 L1. L1 माने p orbital पाई माने 2p पाई. So radial wave function है. एगोटा सब हम मन रखिया पड़ियो को orbital पाई को radial wave function. 2s ପାଇଁ କ'ଣ 1s ପାଇଁ କ'ଣ 2p ପାଇଁ କ'ଣ ଦେଖ ଇଏ ହେଉଛି 1 l a 0 ମାନେ s ଇଏ 1s ପାଇଁ ରେଡିଆଲ ୱେଭ ଫଙ୍କସନ୍ ଇଏ 2 ଇଏ 0 s 2s ଅର୍ବିଟାଲ ପାଇଁ ଇଏ ହେଉଛି 2p ଅର୍ବିଟାଲ କାରଣ 1p ଆମେ ଯେ 0 ହେଉଛି s 1p 2d M3F ଅର୍ବିଟାଲ ଆମେ ପଢିଥିଲେ କ୍ୱାଣ୍ଟମ ନମ୍ବର କୋଉ ଆଜିମୁଥାଲ କ୍ୱାଣ୍ଟମ ନମ୍ବର ପାଇଁ co-orbital. So similarly, 2p ପାଇଁ ଏଇଟା 3s ପାଇଁ ଏଇଟା 3p ପାଇଁ ଏଇଟା 3d ପାଇଁ so these are କ'ଣ different area solution of angular and azimuthal equation. So azimuthal equation it is spherical harmonic you have psi theta by phi theta and g theta spherical harmonics. ତାହେଲେ କ'ଣ ବାହାରିବ different spherical harmonics ବାହାରିବ ତ ଆଦৌ ଆମେ ଜାଣିବା କ'ଣ we get a function here. So azimuthal equation are linked because spherical. So solution of angular and azimuthal equation. तो आमे कौन पाया the radial wave function are spherical harmonic y determines probability density depends on n psi nlm r theta phi radial function and azimuthal function. So quantum numbers तीनटा अछि चारटा अछि स्पिन क्वांटम नंबर आदरे बाहर तो कौन गोटे प्रिंसिपल क्वांटम नंबर गोटे azimuthal गोटे मैग्नेटिक क्वांटम नंबर. So boundary condition n is equal to 1, 2, 3, 4. This is integer. N value 0 ରୁ start ହେବ n ର 1 ରୁ l ର 0 0 1 2. So value of n depends upon n କାରଣ n ଯାହା ହେବ l n minus 1 suppose l ର n ର value 1 l ର value କ'ଣ ହେଇପାରିବ n minus 1 0 to n minus 1 ତାହେଲେ 0 ହେବ 1 ହେବ suppose n ର value 3 ହେଲା ତାମାନେ 0 ରୁ n minus 1 3 ର n minus 1 କେତେ 2 t ହେଲେ n ର value 2 ତାମାନେ 0 1 2 so l ର value depends upon l value. Similarly value of l depends upon the m ର value. suppose କ'ଣ m l ହେଉଛି minus l ରୁ plus l through 0 suppose l ର value 2 ହେଲା तो m ର value minus 2 plus 1 0 plus 2 minus sorry minus 2 plus minus 1 0 plus 1 plus 2. So n l m value depend with each other. So restriction in quantum number said n greater than 0 0 ରୁ ବଡ଼ ସବୁବେଳେ n ହେବ କାରଣ n ର value starts from 1. So n ର କ'ଣ restriction l should be less than n. तो n ର 3 ଥବ l ର value କେବେ 3 ହବନି l ର value ସବୁବେଳେ n ଠାରୁ କମ ହେବ 2 हबो कि 1 हबो कि 0 हबो। Similarly, ml less than equal to L. ml ର value as magnetic quantum number ର L ସହିତ equal ହବ କି L ଠାରୁ କମ ହବ, କେବେ ହେଲେ ତାଠାରୁ ବଡ ହେଇପାରିବନି। So these are the restriction of quantum numbers derived from the Schrodinger equation. So principal quantum number energy can be principal quantum number used to quantization of energy of nth orbital. So En is equal to minus E0 by n square. So this term is E0 by n house nth orbital. तो angular momentum L बाहर जाए angular momentum केमती बाहे azimuthal quantum number L into L plus 1 root over H। तो L ର value 0 बाहर तो आमे कौन बाहर करिया ताको angular गुण 0 into 1 H 0 हो। So L ର value 1 हेले 1 into 1 plus 1 2 ର root over हବ 2 ର root over हବ L ର value। तो angular momentum कौन आम रेडियस एंड मोमेंटम रो मल्टीप्लिकेशन। तो angular momentum रो फार्मूला कौन small l into l plus 1 रो root over small l कौन azimuthal quantum। So from the hydrogen spectra we will get both angular momentum and quantum। So if you get a quantum number, azimuthal quantum number, we will get kana angular momentum here। So listen, quantum angular momentum, degenerate orbital, letter number L value। So L 8 କହିଥିଲି L 0 ହେଲେ s orbital, 1 ହେଲେ p orbital, 2 ହେଲେ d orbital, L ହେଲେ f orbital, 4 ହେଲେ g, 5 ହେଲେ। But we know up to f orbital। ଆମେ ଜାଣିଛେ f orbital ଜାଣିଛେ। This has theoretical values। Atomic states are referred hello, am I audible?
Yes, sir.
तो आम क्वांटम नंबर पढ़ुले क्वांटम नंबर azimuthal क्वांटम नंबर कौन आम जानते L ର value 0 हेले s orbital, 1 हेले p orbital, 2 हेले d orbital, 3 हेले f orbital। तो atomic state referred to by n by s state with n is equal to L is equal to 1 color 2 p orbital। तो आम एटा सब देखिले। So magnetic quantum number कौन so in different direction रे तारा magnetic है। तो आम जानिचे suppose m रा L रा value 2 है तो 2 हेले कौन हबो r value -2 -1 -2 एपटर -2 -1 0 +1 +2। तो ये डिफरेंट मैग्नेटिक की डायरेक्शन इन डिफरेंट है। तो आम जानचे एंगुलर मोमेंटम इज इक्वल टू L into L plus 1 रूट ओवर एटे L रा वैल्यू पकेले L रा वैल्यू पकेले आर एंगुलर मोमेंटम बाहरिबो 6 रूट ओवर H। तो phi is the measure of rotation as z axis। L is equal to mh L into L plus 1 root over 6। तो देखि दिए कौन केमती गोटे L रा वैल्यू 2 पका है कि करा है। सपोज M रा वैल्यू L रा वैल्यू ओके। मैग्नेटिक क्वांटम नंबर एक मैग्नेटिक क्वांटम नंबर पाइले हम एंगुलर मोमेंटम है। तो मैग्नेटिक क्वांटम नंबर So we'll get summation of this one. So this will derive from the L value. L equal. Uh, then energy level of electrons. Energy levels सब होता है देखो एटी L is equal 0 S orbital L is equal to 1 P orbital D होची 2 F हो 3G आर different energy level ଅଛି ଗୋଟେ ଦିଟା ତିନିଟା ଚାରିଟା so this will jump with each other these series so ground state atom so ଗୋଟେ energy level ଆଉ ଗୋଟେ energy ଲାଗେ azimuthal quantum number. So what is the selection rule? Yes, sir. Selection rule माने one electron can emit photon or absorb photon to change states. तो गोटे जगह आउ जो गोटे जगह को जीवो माने गोटे स्पिन स्टेट और azimuthal state रो आउटा स्टेट को what is the allowed condition here delta l plus minus 1 माने रियल हबो कोन प्लस माइनस 1 प्लस 1 हबो धर 2 रु 2 प्लस 2 रु माइनस 2 वाला एटा डेल्टा एल तो कोन 0 हे जिवो हमर कोन 0 रु 1 को जाई परिबो कि 1 रु 0 कि 2 रु 1 को आस पाइबो 1 को 2 सेति पई डेल्टा एल सिलेक्शन रु कोन होची डेल्टा एल इज इक्वल टू प्लस और माइनस 1 तामने 0 रु 1 को जाई परिबो 1 रु 0 को जाइबो 2 रु 1 को जाइबो किंतु 0 रु 2 को जाई परिबो ओके और 2 रु 2 को जाई परिबो सो डेल्टा एच प्लस or minus 1 is allowed transition. Forbidden माने मोना. Delta L is not equal to plus minus 1. Also, what are a delta n anything here? 2n, 3n जते ही पर. Delta L plus 1 delta ml कहता है वो समझे 0 plus or minus 1. So this is the selection rule for transition of electron from one state to another. So delta L is equal to plus or minus 1. So probability distribution, we must use wave function to calculate the probability distribution of electron. So electron quad distribute ହେଇଛି, we must study the wave. So position कोठी, radial कोठी, ଏଟା ସବୁ ପାଇଛି. So probability distribution function ये होଉଛି ତାର function r square sin theta. The function by with radial wave function. The main house hydrogen. So ये distribution function ର different diagram केमती ହେଇଛି wave function radial wave function ର decrease. So R radial option PR for the lowest lying states of hydrogen. So hydrogen atom रे ये कौन ହେଇଛି different radial wave function ଦେଇଛି. So this is the probability distribution. देखो, this is the actual dimension of a orbital. देखो, here n is equal to 2. n 2 माने 2th orbital. Orbital number 2. And cell number 2. L होची 1. L 1 हेले L 0 s 1 हेले p. ml plus minus 1 तामने 2p इको ऑर्बिटल डबल डबल भलिया देखिया 2p p रकेटा px py pz था ये x ही पर y ही पर z to px e to py e to pz ये this is the probability density of hydrogen atom for three different electron states so electron are भीतर ही रहे so this is the probability of finding electron. So electron address होची the electron address कौन 2px. Similarly, n3 l1p 3px और 3pz value 3pz. तो z वाले x ऐसे 3pz. Seventy n3 l2 0. So 3pz value. D होची 2 होची D तामने 3D Z और X and D रो केटा अछि पांचटा अछि D X Y dyz, dzx, dx square y square, dz square. तो आ देहरे कौन ता देहरे 3 l ର value d 2 हेले d 3d xy ହେଇପାରେ 3d z square ହେଇପାରେ ଯାହା ବି ହେଇପାରେ ହ୍ୱାଟ ଏଭର ମେ नो बडी नो सो ये कौन है 3d z square ର value ଦେଇଛି ये 3d z square ର value ये 3p z ର value ये 2p x e orbital रे finding electron सब ଦେଇଛି probability distribution of. So till now we have studied the hydrogen atom. ଆଉ ଥରେ ଟିକେ ଦେଖିଦିଅ ଗୋଟେ ଗୋଟେ ସ୍ଲାଇଡ୍ ମୁଁ ଧୀରେ ଧୀରେ ମୁଭ୍ କରିବି. So you just look at the slides. So this is hydrogen quantum hydrogen atom. धीरे धीरे पढ़ से स्लाइड रे कौन कौन लिखा है. This is another slide. This is another slide. This is another slide. Quantum hydrogen atom. Mathematical treatment, quantum mechanical terms. Then atom. So application of Schrodinger equation in hydrogen atom. Application of Schrodinger equation total. So in terms of radial wave function. Solution in Schrodinger equation.
Incoming call from by to identified by Truecaller.
Solution to Schrodinger equation. Solution to radial wave function, angular wave function. So quantum number sample तीनटा quantum number. Hydrogen atom or other different radial wave function. Azimuthal equation. Angular wave function. So these are different quantum numbers. What is the restriction of different quantum numbers? Principal quantum number ରୁ ଆମେ କ'ଣ ପାଇବା energy. Azimuthal quantum number ରୁ ଆମେ angular momentum ପାଉଛେ. So this is the calculation of angular momentum. तापरे magnetic quantum number ରୁ ଆମେ ପାଉଛେ different directions. So this is the energy levels and this is the selection rule for transition of electrons. This is probability distribution of electrons. Okay. पढ़ुले हार्मोनिक ओसियन ब्लॉक 2 टी देखिदवा ब्लॉक 2. So this is block 2 quantum model. हम हार्मोनिक ऑसिलेटर रिजिड रोटेटर पले हाइड्रोजन एटम 1 2 1 2 रे सब पले angular momentum in one electron atom पड़े angular momentum पले এই ওপর মোটে মেটেরিয়াল দেখি দଉଛି মেটেরিয়াল ଟେ ଦେଖି ଦଉଛି କ'ଣ ଅଛି. ତମକୁ ସବୁ ବହି ମିଳିଲାଣି ପିଲାମାନେ? ହ୍ୟାଲୋ
Yes, sir.
ବହି ମିଳିଲାଣି ନା
Sir, ସବୁ ମିଳିନି ଆପଣଙ୍କୁ.
ମେଟେରିଆଲ ଖାଲି ଲିଙ୍କ ମିଳିଛି?
Yes, sir, link ମିଳିଛି.
ହଁ ଏଆରେ ସ୍କୋଡିଞ୍ଜର ଇକ୍ୱେସନର ସଲ୍ଭ ହେଇଛି। ହଁ ଲିଙ୍କରୁ ଡାଉନଲୋଡ୍ କରିଦେବ ଆଉ ମୁଁ ସରିଲା ପରେ ସବୁ ମେଟେରିଆଲ ମୁଁ ସେୟାର କରିଦେବି ଆଉ।
सर
क्वांटाइजेशन बहुत कुछ रहता है इसका अच्छी नहीं पॉलीनोमियल नॉन लीनियर सेल्स normalizable equation पढ़ाना wave function of harmonic oscillator ସବୁଆଡେ ସେମ୍ ଇକ୍ୱେସନ୍ ଖାଲି ସବୁଆଡେ ଇକ୍ୱେସନ୍ ଏଇଟା ଏଇଟା ମ୍ୟାଥମେଟିକାଲ ପୁରା ରିଜିଡ୍ ରୋଟେଟର ମୁଁ ଯାହା କହୁଥିଲି ରିଜିଡ୍ ରୋଟେଟର ରିଜିଡ୍ ରୋଟେଟର ତା ଦେହରେ ଭଲ ଦେଇଛି ସେମ୍ ଜିନିଷ ସେଣ୍ଟର ଅଫ୍ ମାସ୍ ଅଛି ଏନର୍ଜି ହାଫ୍ ଏମ୍ ଭି ସ୍କୋୟାର ହାଫ୍ ଏମ୍ ଭି ସ୍କୋୟାର ତାପରେ ଇନର୍ସିଆ ଦିଆହବ ପିରିୟଡ଼ ଅଫ୍ ଇନର୍ସିଆ ମେଟେରିଆଲ ଦେଖିଦବ ମେଟେରିଆଲ ସବୁ ସେମ୍ ଜିନିଷ हाफ आई ओमेगा स्क्वायर एल स्क्वायर बाई टू आई कर ना टी इक्वल टू एल स्क्वायर बाई टी क्वांटम मैकेनिक्स डिस्क्रिप्शन ऑफ रिजिड रोटेटर क्वांटम खाली तुम ये अच्छी कमेंट रहा जेड हम जेड पढ़ना था जेड और कौन क्वांटम स्टेट्स problems special polar coordinates for x is equal to I sin theta cos phi y is equal to I sin theta sin phi z is equal to r cos six hydrogen atom hydrogen atom coordinate पढ़ते हैं Ahora estamos Laplaciano operator hydrogen operator separation of mass x square y square x z square 2 psi square x only 40 one होगा 40 हाइड्रोजन हम पहले हाइड्रोजन like ions और लिथियम 2 plus helium plus ये जो हाइड्रोजन like बेरियम 3 plus सब वो है eta phi equation is some normalization some
Incoming call from Arpita Madam Vidya identified by Truecaller.
some ଆଜ୍ଞା। ହଁ ହଉ ହଉ। କୋଉ କୋଉ ଏକ୍ଜାମ? ହଁ ହଁ ହଉ ଠିକ୍ ଅଛି। So this is radial wave function. So खाली देखो mathematical expression खाली in है बहुत सारा radial sambar particle energy in a orbital hydrogen atom part 1 वाला part 2
Incoming call from progressive RACGO identified by Truecaller.
part 2 part 2 hydrogen atom by 2 atomic radius and continuous hydrogen हमें Lyman series Balmer Paschen bracket P from series When infinitive ରୁ L1 କୁ ଆସିବ N1 ସବୁ Lyman series 4 ରୁ 3 3 ରୁ 1 4 ରୁ 1 5 ରୁ 1 ଯୁଆଡେ ହେଲା Lyman ବାଲମାର କଣ 2 କୁ ଆସିବ infinite to 1 Paschen bracket ର P from quantum numbers and their sigma এই quantum numbers জানলে azimuthal magnetic and principal quantum. The principal quantum number, azimuthal quantum number, पढ़िले ଆମେ ଏ ହେଉଛି magnetic angular momentum L into L plus 1 ସବୁ ପଢିଲେ ନେଇକି ତାର ସବୁ ପଢିଲେ wave function of hydrogen atom. So ये ହେଉଛି radial wave function, radial function, angular function. So ଆମେ ଏଇଟା ପଢିଲେ radial ସବୁ distribution curve ये सब different orbital ତାପରେ ଆଉ କିଛି ଜିନିଷ ଆମେ next class ରେ କରିବା ପ୍ରାୟ almost ଏଇ ଯେମିତି ପଳେଇ ଆସିଛି hello audible
Yes, sir.
left ହେଇଗଲାଣି କି class almost ସରିଲାଣି ସାରିଦେବା class
Okay, sir.
ହଁ କେତେ ଜଣ ଆଜି ଜଏନ୍ ହେଇଥିଲେ 4 ଜଣ 5
Yes, sir.
କେତେ ଜଣ
4 ଜଣ।
4 ଜଣ ଆଉ ଆମେ ନେକ୍ସଟ କ୍ଲାସରେ ଆମେ ଅଲମୋଷ୍ଟ ପଢି ସାରିଲେ ହାଇଡ୍ରୋଜେନ ଆଟମ୍ ଦୁଇଟା ରହିବି ତାପରେ ଆମେ ଆଙ୍ଗୁଲାର ମୋମେଣ୍ଟମ ଆପ୍ରୋକ୍ସିମେସନ 3-4ଟା ପଢିବା କ୍ୱେଶ୍ଚିନ୍ ନେକ୍ସଟ କ୍ଲାସରେ କ୍ୱେଶ୍ଚିନ୍ ଡିସ୍କସନ ହେଲା କି
Okay, sir.